A certain SAT preparation school believes that the answers to consecutive questions on the ACT are not independent. That is, they believe that two consecutive questions will have the same answer less than 20% of the time. To investigate, they randomly select 200 pairs of questions and find that 36 pairs have the same answer. Is this convincing evidence at the 1% significance level that the SAT school is correct? So let's look at it. The reason they got 20% is they're saying, hey, you know, when a teacher or the SAT is building a test, if they decide the correct answer for number 1 is A, then they're just going to randomly pick the correct answer for number 2, and it could be C, and randomly pick again where the correct answer will be on number 3, and it could be C again. And since it's usually out of A through E, which is 5 options, randomly picking one of them would be 20%. So that's where they're getting their 20% figure. But what they're trying to tell their clients is actually it's not random. And if you knew that this answer was C and you're not sure how to answer the next question, you probably shouldn't pick C as your guess because it's going to be less likely. It's not as equally likely to be C as the other questions. And so what they did was they looked at 200 pairs, and 36 out of the 200 had matching answers, which should be about 20%, but they got 18%. So they're saying C, it's unlikely, or it's less likely for answers to match next to each other that are correct. So again, if you knew this one was C and you had no idea on 3, you'd be better to guess something else instead of C because it's going to be less than a 20% chance to be C. All right, so it says perform the requirements for hypothesis test for the population proportion. Okay, state whether or not each requirement is met and justify your answer. So first, is it a random sample or randomized experiment? And you can look up here and they said they did a random sample of questions. So you just say, yep, it's random. And you can point out, yes, it's random. Look, it says right here. Next, independent. Well, in order for it to be independent, there has to be a large enough population of questions that pulling out 200 to sample isn't really going to affect who you're choosing each time. So what you do is you say, well, I'm going to take my sample size and divide by 5%, and that means there would have to be at least a population of 4,000 pairs of SAT questions, consecutive questions together that we could choose from. And I'm assuming there are more than 4,000 SAT questions. So you would say, so assuming there are greater than or equal to 4,000 pairs of SAT questions, the sampling can be considered independent. So that's the next part. Next, the part that really makes sure that it's normal besides those two is, did you take a large enough sample? This is the sample size condition. So we are going to do n times p sub null. Whenever we're doing anything but a confidence interval, we use the p sub null, or the theoretical p-value that we claim to know. And so we're going to say 200 times 0.2. That's 40, which is greater than or equal to 10. Check. And same thing, 200 times 1 minus p. So 1 minus 0.2 is 0.8. That is also greater than or equal to 10. So we have an idea that the distribution of all possible samples of size 200 pairs of consecutive ACT questions, SAT, would look normal. And that is good because now instead of having to do one of those simulations like Unit 1, we can use what we know about a normal curve to find how rare it is to get a sample of 18. Because we've got 0.2 or 20%, we got a sample of 18. So we want the probability of getting a sample of 18% of the pairs having the same matching answers next to each other, assuming it's really 20. So you just got a kind of a low sample. Now, I knew where to draw this 0.18 because I found the test score or the test statistic. But before we do that, let's go back and find our hypotheses. So we want to define what we're looking for. We want to find P, the true proportion of consecutive SAT questions with the same answer. And according to SAT, the answers are just random. Okay, they randomly pick where to put the right answers. So the proportion should be 20%. The alternate, according to the SAT school, is that it's less than 20%. Okay, so it says sketch a picture, and we have. You are going to use GeoGebra to do all of this, but let's talk about it real quick. You could find the standard error by doing the square root of p times 1 minus p all over n, and that would just give you the standard deviation on this chart. Okay. And then you could actually find the test statistic. You could say, well, if I took this diagram and instead made the average or the center 0 and the standard deviations 1, how many standard deviations away from 0 is my sample size? And that standardized amount is called your test statistic. And you could find that by doing what you got minus what you expected to get all over the standard error. And our standard error in this case is 2.8% because I figured out the denominator. And our test statistic is 0.707. So what the test statistic means is that 18% they got in their sample is only 0.707 standard deviations below 0. That's not rare. It's not even 1 standard deviation below 0. And I'd already figured that out, so that's where I knew to draw the 18. But you don't have to do any of that by hand. You can put it in GeoGebra. So go to GeoGebra. You're always going to want to use the probability menu. It doesn't like me, so let's see. There we go. And make it bigger. All right, this is where you could figure it out if you're doing any normal curve stuff, and you're not going to do this on tests, but you could. You could have said, hey, we think the center of this curve is 0.2 with a standard deviation, and I found that standard deviation using the square root formula of 0.02828. Come on, computer, there you go. And we want to know the probability of getting a sample of 18% or less. And it says 0.2397. So about a 24% chance that even if all of the SAT questions are random, that I could get a sample with less than 18% of them consecutive having the same answer. Okay, and that's just not that rare. There's almost a 25% chance that could happen. Now, you don't actually have to do this here, though you would jump to the statistics. Okay, if you were doing a confidence interval, you would be down here, and we're going to talk about that in a minute for the estimate of a proportion, but you want the z-test of a proportion. Memorize which one you want, and we say, I think my null is 0.20, but I'm guessing that it's actually less because I got a sample where 36 out of 200, which was 18%. Okay, and notice there is our 0.707. There's our 23.9 that I got before. And so I'm going to fill out this chart just real quick. I will flip over 1 second. Okay, and I should have said this was negative. When I did it, I did lose my negative. All right, so my null hypothesis is 20%. I think that it's less than that. Successes, okay, you had 36 out of 200. And again, it would just fill in there 36 out of 200 for you. Finding your p-hat. Your p-hat standardized is negative 0.707. That's called your test statistic. And this, my friends, right here is your p-value. Okay, your p-value. The probability of getting the sample you got, or smaller in this case, what you got or more extreme assuming the null hypothesis is true, that the mean is 20%. Okay, so that is how you do the last question. Now let's look at it. It says, so then what is our correct decision? Well, we are going to fail to reject the null hypothesis because our p-value of 0.2398, that's not small. It's absolutely not less than or equal to the 1% we were looking for. So you could write something like this. And I'm not going to be super picky as long as you compare the p-value to your alpha, say there is sufficient or insufficient evidence, and have context. Okay, but if you look in your notes, they give you a Mad Lib. So you could just memorize that or put that on your cheat sheet. So here we go. Since my p-value of 0.239 is not less than alpha of 0.01, I fail to reject the null hypothesis. There is insufficient evidence to conclude consecutive questions have the same answer less than 20% of the time. Okay, this 18% was not far enough away from 20 to make me really feel like I had enough evidence. So there's the end of that. Now I really quickly want to add on to this and say you could have answered the same question with a confidence interval. We took a sample and got 18% in the middle. Okay, now let's say we wanted to do a 95% confidence interval. Okay, the tests on the confidence interval, the alphas relate to the confidence interval level. So if you had an alpha of 0.05, you do a confidence interval level of 95, but that's only if you're doing a two-sided test. And I don't want to get into that right now. So let's just say I wanted to think about it differently. Instead of having an alpha of 0.01, I just want to say, hey, what would happen if I tried to make a 95% confidence interval for the same question? So I'm going to go back over here and this time do a z-estimate of a proportion. I want a 95% confidence interval. Here's my data, and it says my lower limit would be 12.1268, and my upper limit would be 0.232, okay, with a margin of error right here of about 5%, 5.32%. So take 18 and plus or minus 5.3. Well, how could this actually answer our question? Let's go back and think about it. Our null hypothesis says we think the real value is 20%. Well, we just did a confidence interval where we are 95% confident that this interval right here captures the true percent. Hey, is 20% in there? Yeah. So that's another reason to say, yeah, we think it could still be 20%. This is just happens to be a low sample. We do not have enough evidence to reject the null hypothesis and conclude it's less than 20%. Okay, good luck studying. Fill out a cheat sheet. Please do all the reviews. Okay, you've had access to the reviews from Unit 3 Quiz 1 and Unit 3 Quiz 2, but you also have access through everything through the midterm 2 review section as well. They're the same reviews, but they also have flashcards, so check it out. Thank you.